Section 2.6 is talking about solving inequalities, and when you solve your inequality, it wants you to express your solution as intervals. So I just want to make sure that we understand the different kinds of expressions when you can do. So you have inequality notation, which is when you have your less than, your greater than signs with numbers, whether you have them by themselves or whether you have it as a compound inequality. Then your set notation is when you have like the solution sets and it's like x such that, and then you have an inequality. And then the third one is interval notation, and this is when you're using your parentheses or your brackets. Okay. So when we're finding our answers, we're going to want to express them as interval notation. And this is a common notation you will see as you advance in math classes. Everything will move up kind of wanting to be expressed as interval notation, whether you're talking about domain or range or solving. Okay. All right, so when we're solving inequalities, for today we're going to be dealing with just linear inequalities and absolute value inequalities. So the goal is you want to get your variable by itself. I like to move the variable to the left-hand side, but it doesn't matter as long as you know how to read it. So on number 1, the first thing I would do is I would subtract 2x from both sides. So then I would have 2x minus 3 is less than 5. Then I would add 3 to both sides. So I have 2x is less than 8. And then I would divide both sides by 2. So this would be x is less than 4. So that was what it would be like as inequality notation, but we want to write it as interval notation. So if I want to say x is less than 4, that means every number smaller than 4 works. So my inequality would be from negative infinity to 4. Since this does not have an equal to sign, we use parentheses. If it had an equal to sign, we would use brackets. So this is my answer. And these are, I know these are not points because I know they're intervals. So when you're doing it, I can tell the difference between what a point is and what an interval is. Okay, and number 2, we're doing the same thing. We want to get x by itself. So I would subtract 4 from both sides. So I have negative 3x less than or equal to 7. Okay, remember on inequalities, when I divide by a negative, so I'm going to divide by a negative 3, that is going to flip your sign. So you can leave this as negative 7/3, or if you prefer mixed numbers, that's fine, which would be negative 2 1/3. Okay, so I want to write this as an interval, so I'm going to use a bracket because it has an equal to sign and it's greater than this number. So I'm going to go from this number to infinity. Okay, infinities never have brackets because you can always have one number bigger than the next one you can think of. And then this one would have a bracket. Okay, with a compound inequality, like number 3, we want to get x by itself on the inside. So if I were to get x by itself on the inside by number 3, the first thing I would do is I would multiply everything by 5. When I say everything, I mean the left-hand side, the middle, and the right-hand side have to get all the operations. So I'd have 15 less than or equal to 2x minus 9 less than 35. Then I would add 9 to everywhere, so I have to add it to the middle, to the left, and to the right. So 15 plus 9 is 24. Equal to 2x less than 44. Now I divide everything by 2. So I would have 12 less than or equal to x less than 22. So if I want to, so what this says is it says x is less than 22, but it also has to be greater than or equal to 12. So it's from 12 to 22. 12 has a bracket because it has the equal to. 22 has a parenthesis. Okay, important thing to remember, when you're doing interval notation, the numbers always go from least to greatest. Okay, they did the same thing on number 1, like negative infinity was smaller than 4, so it goes from negative infinity to 4. You always go from least to greatest. Okay, on number 4, the first thing I would do is I need to get rid of my parentheses. So I would, on the left, I would need to write this out twice and distribute. On the right-hand side, I would distribute, so I'm going to go ahead and do that on the right. So that would become x squared plus 12x. Then on the left, I would have x squared minus 4x plus 16. And if I combine like terms on the left, I have x squared minus 8x plus 16. Okay, I have an x squared on both sides, so those just cancel. So if you get x squareds or x cubes or anything higher than a linear, they should cancel on both sides. If they do not, then you know you've done something wrong. We're not doing quadratics yet. That is in the next section. Okay, then I'm going to get my x's on the same side, so I'm going to not add, I'm going to subtract 12x. Now, if you want to move your x's on the right, that's fine. I just like to be consistent. So I have negative 20x plus 16 greater than 0. Then I would subtract 16. So I have negative 20x greater than negative 16. Divide by negative 20, so divided by a negative means I'm going to flip my sign. Two negatives make a positive, and those are both divisible by 4. So this would be 4/5. So x is less than 4/5 means I would go from negative infinity to 4/5. And there's no equal to sign, so we have parentheses. Okay, so these are your linear ones. Okay, the other kind you're going to see in one variable are your absolute value. So on absolute values, if you remember when we were solving your equations, you have two answers. Because you can take the absolute value of 4 and get the answer is 4. You can take the absolute value of negative 4 and also get the answer is 4. So you're going to have two answers on equations. On inequalities, it's very, very similar. You're going to have two parts. So I always try to think of it as like less thans are going to be ands. That means when I solve this, ands should go together. And then greater than or greater than are ors, which means I solve it, they're going to go apart. Now determining which one you are is going to be determined once you get the absolute value by itself. So on number 5, the absolute value is by itself. So when I solve, just like with equations, you're going to have two parts. Your first part stays the same. Now on equations, I don't know why I have the absolute value there, sorry. On equations, you would just change the sign on the right. On inequalities, you have to change the sign and flip. Okay? Sorry. On equations, you would just make it negative. On inequalities, you have to make it negative and flip the sign, because when you divide by a negative, you would have to flip the sign. So those are my two inequalities that I'm solving. So on this one, I would subtract 5. So I have 2x less than negative 1. Divided by 2, x is less than negative 1/2. On the second one, I would subtract 5. So I have 2x greater than negative 9. Divide by 2. X is greater than negative 9/2, which I'm going to write as a mixed number, 4 1/2. Okay, When I say and, that means these should go together. So if I look, less than -0.5, greater than -4.5, those should meet up together. So when I write this, I'm going to write it as one interval. So it would be from -4.5 to -0.5, because -4.5 is smaller, -0.5 is greater. These will have parentheses. If they're going apart, if they're not going to connect together and they're going apart, then we would have two different intervals. But these are going together. Less than -0.5, greater than -4.5, those are going to meet up. Okay, on number 6, I have to get the absolute value by itself first before I can determine what is going to happen. So the very first thing I'd have to do is add 0.3 to both sides. So the absolute value of x minus 3 is greater than 0.4. Okay, greater than, those are your ors. That means that they should go apart from each other. So when I set them up, I'd have x minus 3 greater than 0.4. And then you have x minus 3 less than -0.4. So when you're writing your second one, you change the sign and you make it negative. So then I would add 3. So I have x is greater than 3.4. Add 3. X is less than 2.6. Greater than 3.4, less than 2.6, those do not meet up. Okay, so this would be -infinity to 2.6 union, which means and 3.4 to infinity. Because x is less than 2.6, so 2.6 down. X is greater than 3.4, so 3.4 up. U means union, which is like and, includes it. Okay, on the last two, these are kind of your special equation ones I want you to make sure you pay attention to. If you have an absolute value that is by itself and it is less than a negative number, that can never happen. Absolute values always have to be greater than a 0. Okay, so if I have the absolute value is less than -1, I can't even, there's no need to even solve this because my answer is going to be no solution. Okay, now in a similar fashion, if it is greater than a negative, absolute values are always greater than negative. So this would be your all reals. Now how you write that in interval notation is -infinity to +infinity. So make sure you pay attention when you're doing your absolute values. Now this is once they are by themselves. You can't tell if you're looking at a big long equation. You need to look, once you have the absolute value by itself, what is going on. This concludes your notes for 2.6.